Hello, am I audible? Can anyone confirm? Hello.
Yes, sir.
Okay. Is my screen visible?
Visible.
Okay, thank you. So, good afternoon, everyone. Welcome to this NPTEL live session. This is the week 10 of this NPTEL live sessions for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this session we will solve some practice problems mainly on clustering based on hierarchical clustering, k-means, and some questions on DB scan, cure, and also batch. So we will solve some practice problems on these topics, and also I will try to answer your questions and doubts. If you have any doubts, please feel free to ask me. So we can start the problem solving session now. So this is question 1. Suppose you have a single cluster of data points, and the data points are -2, -2, -1, -2, 2, 1, 1, 2. These are the 4 points that you have been given. Find the point x which has the highest average L2 distance with respect to other data points. So to find the point x out of these 4 points which has the highest average L2 distance with respect to the other data points. So L2 distance is nothing but the Euclidean distance. So you have to find out the point which has the highest average Euclidean distance with respect to other points out of these 4 points that are given here. You can write your answers in the chat. So basically you have to find out the distance from one point to all the other points, and then you have to find out the average of all the distances that you get from a given point. So has anyone calculated it? If you have calculated the answer, you can write it and write your answer in the chat. So for this question, you have to find out the distance from one point to all other points. So for example, you pick minus 2, minus 2. So from this point you have to find out the distances, distances to all the other points. So these are the 3 other points. You have to find out the distances, all these 3 distances, and you have to find out the average of these 3 L2 distances. So L2 distance is very easy to find out. So minus 2, minus 2 and minus 1, minus 2. So this distance would be 1 square plus 0 square, so it would be 1. Similarly, the distance between minus 2, minus 2 and 2, 1 would be 4 square plus 3 square, so that would be 25. And then the distance between minus 2, and 1, 2 would be 3 square plus 4 square, which is also 25. So now the average is 1 plus 25 plus 25 by 3. This is the average L2 distance from this point minus 2, minus 2 to all other points. So this is 51 by 3. So similarly you have to find out these average distances for each of these points. So I have just computed for minus 2, minus 2, and now you have to do the same for minus 1, minus 2, then 2, 1 and then 1, 2. So for all these 3 points you have to repeat the same process, and then you have to calculate this average L2 distance, and you have to find out the highest average L2 distance. So if you calculate for all these all 4 points, you will find out that option A, minus 2, minus 2 is the right answer, that it has the highest average L2 distance with respect to all other points. So that is what you have to do for this question. Does anyone have any questions or doubts in this question? So L2 distance basically means Euclidean distance. You have to find out the Euclidean distance from one point to other, and that way you have to find out the average L2 distance. Distance is 5, not 25. Yeah, so L2 distance basically means the square of it, and even if you take the square root, it doesn't really matter, because you just have to find out the highest average L2 distance. So if the squared value is highest, the the square root value would also be the highest, isn't it? So answer would not change for that. But L2 distance basically means without the square root, not exactly the Euclidean distance, square of the Euclidean distance. So L2 distance, that means x1 y1 is one point, x2 y2 is another point. So L2 distance would be x1 minus x2 whole square plus y1 minus y2 whole square. So this would be the L2 distance, and if you want to find out the Euclidean distance, that would be square root of this. So answer would not change whether you are taking the squared value or the square root value. The highest would still be the same. So minus 2, minus 2, option A would still be the correct answer, whether you take the square root or not. Is it fine? Okay, so let's move on to question 2. This is on k-means clustering. So which of the following statements is or are not true about k-means clustering? So you have to find out which statement is not true. There might be multiple correct answers, so is or are not true. So there are 4 options. It is an unsupervised learning algorithm. Overlapping of clusters is allowed in k-means clustering. It is a hard clustering technique, and option D is k is a hyperparameter. So these are the 4 options. Which of these options is or are not true about k-means clustering? You can write your answers in the chat. Karthik Juneja says option C, which is it is a hard clustering technique, and Prashant Sahu says B, which is overlapping of clusters is allowed in K-means clustering. Okay. So any other answers? Anyone else? I've got B and C from the chat. So does anyone feel some other option would be correct? So in this question, option B would be the correct answer, that overlapping of clusters is allowed in K-means clustering. This is not true. So I have asked which of these options is not true. So if we go through all the four options, so first option is it is an unsupervised learning algorithm, which is correct. Overlapping of clusters is allowed in K-means clustering. This is not true. That's why this will be the answer. Option C is it is a hard clustering algorithm. It is a hard clustering algorithm because in hard clustering algorithms, a given point can belong to only one cluster. In soft clustering techniques, a point can belong to multiple clusters. That's why we call it soft clustering, that each point can belong to multiple clusters, which is not possible in hard clustering, and it is also not done in K-means. So K-means is a hard clustering technique. K is a hyperparameter. This is also true. We can change the value of K and rerun the algorithm. This is like a hyperparameter for this algorithm. So this is also true. So the only option which is not true is option B, and option B would be the correct answer. Overlapping of clusters is not allowed because it is a hard clustering algorithm. Clusters cannot overlap. So if clusters cannot overlap, a single point cannot belong to multiple clusters. So that's why option B is the correct answer. Option B would be the correct answer here. This is question 3. Which of the following is or are some of the assumptions made by K-means clustering assuming Euclidean distance measure? So what are some of the assumptions made by K-means clustering? 4 options are given and multiple answers might be correct here. So 4 options are: clusters are spherical in shape, clusters are of similar sizes, data points in one cluster are well separated from data points of other clusters, there is no wide variation in density among the data points. So these are the 4 options and multiple options might be correct here. Karthik Juneja says D, which is there is no wide variation in density among the data points. Okay. Anyone else? Any other answers? Prashant Sahu also says D. So question is, which among the following is or are some of the assumptions made by K-means clustering? So in K-means clustering, the assumptions are that clusters are spherical in shape. This is correct answer. Clusters are spherical. This is a major assumption made by K-means, which is not always true, but this is an assumption that is made by K-means. And clusters are of similar sizes. This is another correct answer here. So these are the 2 assumptions that are made by K-means clustering. Option C and D are not true. That data points in one cluster are well separated from data points in other clusters. This is not assumed by k-means clustering, and it does not take care of that thing at all, whether the clusters are well separated or not. And option D is there is no wide variation in density among data points. So it doesn't think about density at all. K-means doesn't think about density at all. So it just tries to find out the Euclidean distance of every point from the centroid, and based on that it allocates every point to some cluster, the closest cluster. So in that sense, option C and D are not true. The only assumptions made by k-means are that the clusters are spherical in shape. The clusters produced by k-means are always spherical. That is a problem, because the density based clustering approaches try to fix that thing, that clusters are not always spherical in shape, and clusters are of similar sizes. This is also another thing, because we use Euclidean distance measure from the centroid. So the clusters that k-means should output are always of similar sizes. So that's why option A and B are the correct answers, and C and D are not true here. These are the two only assumptions that are true in this question.
Sir, can you explain this question again? I'm sorry, I missed.
So the question is, which among the following is or are some of the assumptions made by k-means clustering, assuming Euclidean distance measure is being used for the k-means clustering. So what are the assumptions that are made by k-means clustering? The four options are there. So out of these four options, the two major assumptions that are made by k-means clustering are that clusters are spherical in shape. This is a major assumption that k-means assumes, but which is not always true, but it assumes that clusters are always of spherical shape. And as it uses Euclidean distance measure, so clusters are always of similar sizes, which is also not true in many cases, but this is another assumption that it takes. So these are the two correct options, A and B, that clusters are spherical in shape and similar sizes. And the option C and D are not true. The C is data points in one cluster are well separated from data points of other clusters. So data points, it doesn't care about whether clusters are well separated or not. It just finds the Euclidean distance from the centroid to all the points, and based on that it allocates every point to some cluster. So option C is not right, that clusters are well separated. Clusters might not be well separated. And option D is there is no wide variation in density, so it also doesn't take care of the density of the points. The density based clustering algorithms like DB-scan thinks of that, it takes care of that thing, but k-means doesn't assume anything regarding the density. It doesn't think about density at all. It just tries to find out the Euclidean distance, based on that it allocates it creates the clusters. So option C and D are not true. A and B are the two correct assumptions made by k-means.
I'm a little bit unclear about option B, saying clusters are of similar size. So how is that assumption being made through the algorithm? Like how is it being
So for example, let's consider two clusters. So this is one cluster, this is another cluster. So let's consider this is the centroid for this is the centroid for this cluster. So this is like all the points left of this straight line would always belong to this cluster, and all the points right of this belongs to this cluster, isn't it? So it tries to find out the distance from the point. So distance from the centroid it tries to find out, and so all the clusters that will be created would be of similar sizes in that regard. Is it right?
But wouldn't that be more relevant, or rather, wouldn't that only happen, or like wouldn't that be dependent on the dispersion of the points in space?
I'm not able to hear you properly. Can you be a little louder?
So wouldn't the size be dependent on the dispersion of the points in space? Yes.
No,
Because
if for any
you could have a very small but very tight cluster, and in another case you could have like a very kind of spaced out.
no, I mean these are the
Right?
no, these are just the training points that I have drawn. Now for any given test point, any point can be given, these which are not part of the training data. So you are given this point and you are asked which cluster it belongs to. So I can easily see that this belongs to this cluster because it is closer to this centroid. So similarly, if some other cluster would have been there, so it would break the so this is possibly another cluster. So it would break the space into 3 equal parts, isn't it? It would always break the overall hyperplane into equal parts because it just uses the space.
Clusters more as
No, I mean not this circular shape that I am drawing, not exactly that, because this circular shape is just showing which are the training points that it belongs to it. But any point can be given as a test point and you would be asked in which cluster it belongs to. So that way it always breaks down the overall hyperplane into several equal parts because it uses Euclidean distance.
Right.
Yeah. So they are the
Spherical because we are looking at distance from single.
yes. So spherical. I mean spherical because we are using Euclidean distance again. So the Euclidean distance is similar to spherical shape. So that's why. These are the 2 correct answers. Now coming to question 4, considering single link and complete link hierarchical clustering, is it possible for a point to be closer to the points in other clusters than to points in its own cluster? If so, in which approach will this tend to be observed? 4 options are there. Know that it is not possible for the point to be closer to other clusters than points in its own cluster. Option A is that. Option B is yes in single link clustering. Option C is yes in complete link clustering. Option D is yes in both single link and complete link clustering. So in which of these clustering approaches this might happen, that a point is closer to points in other clusters than in its own cluster? You can write your answers in the chat.
Complete link, right? Because we are taking the maximum distances between 2 points.
Complete link, okay, not in single link. Anyone else? So here the correct answer would be D, that in both single link and complete link it is possible. So so D would be the correct answer, because in complete link it is very much obvious that it is possible. In complete link the distance between 2 clusters is the distance between the furthest 2 points in the 2 clusters. So this is very much possible in complete link. But in single link also it is possible if you consider 2 clusters like parallel lines like this. This is one cluster, this is another cluster forming because of some training points. So single link cluster would be able to find out these 2 clusters, these parallel chains, and in this case for a point here, these points are much closer than this point here. So this distance would be much higher than this distance. So for this point, for this point, these points are much closer than this point. So points in other clusters would be closer than points in its own cluster. So that's why in single link also it is possible, and single link clustering would be able to find out such clusters, such parallel chains, 2 parallel chains. It would be able to find out such clustering using single link agglomerative hierarchical clustering also. And complete link, it is very much obvious that as we are the distance measure is the distance between the 2 farthest points in 2 different clusters. So this is very much possible in complete link clustering. and using this example we can show that it is also possible in single link clustering. So that's why option D would be the correct answer. So is there any questions or doubts on this question? So this is question 5. This is on Cure clustering algorithm. So in the Cure clustering algorithm, representative points of a cluster are moved a fraction of the distance between their original location and the centroid of the cluster. Would it make more sense to move them all a fixed distance towards the centroid instead? Why or why not? So these are the two options. That option A is yes, because this approach will ensure that the original cluster shape is preserved. Option B is no, because this approach will not be effective against outliers as the original approach. So whether we can remove the fractional movement with a fixed movement of the representative points towards the centroid. Anirban says no. Okay. Anyone else? Any other answers? Prashant Sahu also says no. Okay. So correct answer here is no, option B. The two of you have already written it in the chat. So in Cure, as you have already learned from the video lectures, that if this is the centroid and this is a representative point, so we move this representative point to a new location. This is a virtual point. No, this representative point is not a real point. By using some fraction alpha, so we move this point towards the centroid. So the further the representative point is, the more the movement. So if the point is here, then movement is much more. Movement will be much more. So this ensures that we are able to preserve the shape of the cluster, and also we are able to ignore the outlier points. But if we move all the points with a fixed distance, then the shape of the cluster would not be preserved, and also the outlier points problem would not be resolved also. So that's why in option B would be the correct answer, that by moving the points at with a fixed distance would not be better than moving with a fractional distance. So that's why option B would be the correct answer. So option B. So the detailed solution is given here, that moving representative points towards the cluster centroid helps in overcoming the effects of outliers. In the proposed approach, moving only a fixed distance toward the centroid would be less effective against the outliers, since the distance between the outliers and the centroid may be much larger than the distance between the other points and the centroid. So it would be much lesser effective against the outliers. So it would not be better. Now moving on to question 6. This is on DB scan algorithm. So suppose while performing DB scan, we randomly choose a point which has less than mean points. This is one of the hyperparameters that are used. Mean points number of points in its neighborhood. Which among the following is true for such a point? 4 options are given. So we randomly pick a point and it has lesser than mean points number of points in its neighborhood. So which of the following is true for this point? Option A is it is treated as noise and not considered further in the algorithm. Option B is it becomes part of its own cluster. Option C, depending upon other points, it may later turn out to be a core point. Option D, depending on other points, it may be density connected to other points. Density connected, or it is also called boundary points. So option D can also be depending upon other point, it may be a boundary point. So which of these 4 options is correct? Honor one says D, which is depending upon other points, it may be densely connected to other points. Okay. Any other answers? So the randomly chosen point has lesser than mean points number of points in its neighborhood. So that means it cannot be a core point. So that is first thing, that core points are those points which have more than mean points number of points in its neighborhood. So it cannot be a core point. So it can either be a noise point or a boundary point, or this thing is same, density connected to the other points, that is also known as boundary point. So these are the 2 only options possible. So depending upon other points, it might happen that later on we find out a core point which is in neighborhood of that point. So that randomly picked point has lesser than mean points number of points, but one of those neighboring points is a core point, then it becomes a boundary point. The randomly picked point would become a boundary point, or the point is density connected to other points. So option D is the correct answer. So option A, which is it is treated as noise point and not considered further in the algorithm. Initially it might be treated as noise point, but later on if we find out that some core point is in neighborhood of that point, so then it is no more a noise point, it becomes a boundary point. And option B says it becomes part of its own cluster. This is not true, obviously, because it has lesser than mean points number of points. So a cluster would be if it had been a core point, then only it becomes a cluster of its own. Option C is depending upon other points, it may later turn out to be a core point. It cannot be a core point because it has less than mean points number of points in its neighborhood, so it can never be a core point, but it can become a boundary point which is densely connected to other points. So option D is the correct answer. So option D would be the correct answer. So explanation is also given. Since there are less than mean points number of points in its neighborhood, it is not a core point. However, it is not necessarily a noise point, since there exists a core point in whose neighborhood this point lies in. It can be a boundary point. So if we find out that there is a core point in its neighborhood, then that point becomes a boundary point. Otherwise, it might be a noise point, but never a core point, because core point should always have more than main point's number of points in its neighborhood. So option D is the correct answer. Let's move on to question 7. Which of the following can act as possible termination conditions in k-means? There are 4 options and multiple options might be correct here. So option A is you have to find out the possible termination condition for k-means. Option A is for a fixed number of iterations. Option B, assignment of observations to clusters does not change between iterations except for the cases with a bad local minimum. Option C is centroids do not change between successive iterations. Option D is terminate when RSS is just the loss function that is used in case of k-means. So terminate when RSS falls below a threshold. So which of these 4 options can be used as termination condition for k-means? There can be multiple correct answers here. Anirban says all could be used depending on data. Okay, that means all 4 options are correct, you are saying. Anyone else? Prashanta Sahu says B and C. So B is assignment of observations to clusters does not change between iterations, and C is centroids do not change between successive iterations. So Prashanta Sahu says B and C. So all 4 options are correct here. All 4 options can be used as possible termination conditions. So first option is number of iterations, fixed number of iterations. It is heavily used, that you fix the number of iterations based on your observation that after 10,000 iterations it would obviously converge. So if you are very certain about that, you can use fixed number of iterations as the termination condition. Option B is assignment of observations to clusters does not change. This is also a popular termination conditions, that the clusters are not changing. That means it has already converged. It might also be a local minima, but mostly that does not happen. So option B can also be used. Option C is centroids do not change between successive iterations. This is also very popular condition for terminating, that centroids are not changing. That means the cluster assignments are also not changing between iterations. So the algorithm has converged. And option D is terminate when RSS falls below a threshold. This is also used, that you have a known threshold loss value or the RSS value, and you just want the loss value to go below that, and whenever it goes below that threshold value, you terminate this algorithm. You don't have to go further. It might not be the global minima, but still you terminate it. So that is also possible. So all four options can be used to terminate k-means clustering. So A, B, C, D, all four are correct answers here. Now question 8. So this is an hierarchical clustering. So in the figure below, if you draw a horizontal line on the y-axis for y equals 2, this is the line you draw, y equals 2, this yellow straight horizontal line that you can see in the figure. So if you draw this line, what will be the number of clusters formed if you terminate the process at this stage using this y equals to 2 horizontal line? So how many clusters will be formed? There are four options: 1, 2, 3 and 4. Anirban says B, Prashanta Sahu says 2, which is option B. So both of you are telling option B. Anyone else? Does anyone think some other option would be correct here? So such cluster merging trees or structures are called dendrograms. So this is one of those dendrogram structures. So it is showing how smaller clusters are getting merged to form bigger clusters in agglomerative hierarchical clustering. And if we stop at y equals to horizontal line here, so at this point we have received two clusters. This is one and this is one. So we would have two clusters at that point, and if we stop at this point, so only two clusters would be formed. So option B, 2 is the correct answer. So this dendrogram is showing that A and B are getting merged to form a bigger cluster, then D and F are merged to form this, and this is merged with E to form a bigger cluster, and then C is merged with this one to form a bigger one. So that way two clusters are formed at y equals 2 straight line. So that's why option B, 2 is the correct answer. B is the correct answer. Now moving on to question 9. In which of the following cases will k-means clustering fail to give good results? So four options. Which of these following cases will k-means clustering fail to give correct answer? Option A is data points with outliers. Option B, data points with different densities. Option C, data points with round shapes. Option D, data points with non-convex shapes. So in which of these cases k-means might fail to give correct results or good results? Multiple options might be correct here. Anirban says AD maybe, but possibly also depends on outlier distribution. Okay, so Anirban says A and D. So anyone else? Any other answers? So the first option is data points with outliers. So option A is one of the correct answers. A is correct, that and it is well known that k-means doesn't work well with outliers. If there are outliers, it might not be able to detect those outliers properly, so it would not give a good result with those outliers. Option A is right. Option B is also right, because it doesn't work with densities. It doesn't detect densities at all, so that's why we use density based clustering algorithms like dbScan and some other algorithms, which works well on different densities. So it is not able to detect different densities, it just finds out the Euclidean distance. So option B is also correct. Option C, it will not fail with round shapes, so option C is not the correct answer. It detects round shapes only or spherical shapes only, because it uses Euclidean distance. So that's why option C is not the correct answer in this question. Option D is right, that it struggles with non-convex shapes also, because it just finds out spherical shapes, so it would not work well if the shapes are non-convex, then it would also fail to give a good result. So A, B, D, these are the three correct answers, A, B and D.
Could you explain B again? So like, because I think we just discussed that it doesn't, k-means doesn't really consider the
densities. So
even if the shape is round, then density doesn't really play a major part, does it?
No, I mean, that is why we use density based clustering algorithms, that based on densities we might have different clusterings. If we don't consider density, then the clustering might be different. If we consider density using density based clustering algorithms, then the clustering might be completely different. So that's why that's why the k-means doesn't work with the different densities at all. So it doesn't take density into consideration anyway, so it just finds out the distances. So if you go through dbScan, the motivation is that k-means and some other algorithms doesn't work with densities at all. So that's why we use the density based clustering algorithm. That is the motivation behind that, that densities might also play an important role in forming the cluster shapes. So that is why B in the different data points with different densities, k-means will fail. So that is why B is correct here. So A, B, D, these are the four correct options. So question 10. So this is on RAND index, one of the accuracy measurement tools for clustering, I mean comparison tools basically. So suppose we have the following data set of 5 elements. We have 5 elements A, B, C, D, E, and we are using two different clustering methods, method 1 and method 2. So method 1, the clustering assignment for method 1 is this. So this is for A, B, C, D, E. So method 1 creates two clusters only, 1 and 2, and it assigns A, B and A, B, C. These 3 points are assigned to cluster 1, and D and D are assigned to cluster 2. Similarly, in method 2, the cluster assignments are 1, 1, 2, 2, 3. That means A and B are assigned to cluster 1, C and D are assigned to cluster 2, and E is assigned to cluster 3. So these are the two clustering assignments using two different clustering methods, method 1 and method 2. And rand index is defined as R equals A plus B divided by NC2. So n here is 5 because we have 5 elements, and A and B are defined here. A is the number of times a pair of elements occur in the same cluster in both sequences. So we take one pair of elements out of these 5 elements we have A, B, C, D, E, and we check whether both the elements in that pair is occurring in the same cluster or not in both the sequences. These are the two sequences. This is sequence 1, this is sequence 2, using two different methods. So that is A, and B is exactly the opposite, that the number of times a pair of elements occur in different clusters in both sequences. So now you have to calculate the rand index between these two clustering methods. So I hope the rand index is clear. Do I have to explain it again, the definitions of A and B, or is it clear from the slide? Anirban says 0.6. Okay, has anyone else computed this? You can write your answer in the chat if you have computed. So for this question, first you have to compute A and B. These two values you have to compute. So A says that A is the number of times a pair of elements occur in the same cluster in both sequences. So there are two sequences, 1 and 2, that I have already written here. Two sequences coming from two different clustering methods. So now you have to compute how many pairs are there such that both the elements are occurring in the same cluster in both the sequences. So AB is one pair, AC is another pair, AD, AE. So and then BC is another pair, BD, BE. So that way you have to form all the pairs. And how many pairs should be there? So there are 5 elements, so it will be 5C2, 50, total 10 pairs can be formed. And now out of those 10 pairs, how many would be in A? So if we try to find the value of A, so AB, if we consider AB is 1 1 in first sequence and also 1 1 in the second sequence. So AB satisfies this criteria for A. So A is 1 now, and if you go through this, you will not find any other pair which satisfies the condition for A, that both the elements are occurring in the same cluster in both the sequences. If you consider AC is 1 1 in first method but 1 and 2 in the second method. Similarly AD, it's 1 2 in the first method but 1 2, so these two are already different. So and DE is DE, both are 2 in first method but not same in the second method. So AB is the only pair that is coming under the value of A. So A is 1, that's why. And now we have to find out the value of B. So B is number of times a pair of elements occur in different clusters in both the sequences. So different clusters. So A and D are occurring in different cluster in first sequence, also in second sequence. Similarly, so AD is 1. AE occurs in different different clusters in the first sequence, also in different cluster in the second sequence. So similarly AE would also be there. And then for BD would also be there in small b, because B and D 1 2, and in the for second sequence also it is 1 2. So it is occurring in two different clusters in both the sequences. BE also satisfies the same criteria, and CE does the same. So these are the 5 elements that are satisfying the condition for B. So B would be 5. So A is 1 and B is 5. So it would be 1 plus 5 divided by 5C2. So 6 by 10, which is 0.6. So 0.6 would be the correct answer. So this is here I have explained it again, that AB is the only one that satisfies the criteria for A. So A is 1 only, and to calculate B, these are the 5 pairs that we can find out. And so B is 5. So rand index would be 6 by 5C2, which is 6 by 10, which is 0.6. So 0.6 would be the correct answer. So this is how you have to calculate rand index, and it shows similarities between two different clustering methods, how similar the two clustering methods are. So is there any questions or doubt in this? Now moving on to question 11. So this is on Barch. So consider 3 points in a cluster 1 1 2 5 6 8. So these 3 points belong to a single cluster in Barch. Now compute the Barch cluster features for this cluster. So you have to compute the cluster feature, Birch cluster feature. The cluster feature in Birch is a 3 tuple, so you have to compute that thing, and 4 options are given, and these are the 3 points in the same cluster. So you have to use these 3 points to compute the cluster feature for this cluster. Anirban says C is 3, 9, 14 as a vector and 131. Okay. Anyone else? Any other answers in the chat? So in Birch, the cluster feature is a 3 tuple. So the 3 elements in that 3 tuple are n, which is the number of points in the cluster. Then linear sum, this is a vector. So linear sum is just the vector summation of all the points in that cluster. And squared sum, this is a scalar. So this is a vector, but this is a vector, but the squared sum is a scalar. This is not a vector. So these are the 3 elements present in a cluster feature in case of Birch algorithm. So n here is 3. So there are 3 points. So n would be 3. LS vector or the linear sum. So we just have to add up all the points. So these are the 3 points. So if we do a linear sum, vector sum of these 3 points, so we have to add component wise. So 1 plus 2 plus 6 is 9, and 1 plus 5 plus 8 would be 14. So this LS, this is LS. And now what about squared sum? So squared sum is just you have to square all the components and add for all the points. So it will be 1 square plus 1 square plus 2 square plus 5 square plus 6 square plus 8 square. So if you add this thing up, it will be 131. So it will be 3, 9, 14, 131. So this would be the cluster feature for this cluster. Option C is the correct answer. So this is how you have to calculate it. Option C. Now question 12. So this is the last question. So you are given a similarity matrix, and based on that similarity matrix, if you apply single link clustering, hierarchical clustering algorithm, what would be the clustering structure? Four options are given: A, B, C, D. How different clusters would be merged? So you have to find out the hierarchy based on this similarity matrix that is given to you for 6 points. And you have to use single link clustering algorithm. And please note that this is a similarity matrix, not distance matrix. So similarity is inverse of distance, so you have to keep this thing in mind. Has anyone found the answer? Prashanta Sahu says D. Okay. Anyone else? Anirban also says D. So I've got two answers, both are saying D. Okay, so for this is a similarity matrix, so you have to find out the highest similarity to merge two clusters. So you have to so initially all 6 points would form different clusters. So 1 2 3 4 5 6, there will be 6 clusters at first. Then from the matrix we have to find out the highest similarity value. So the highest similarity value except these diagonal points, so we cannot consider those diagonal points. So except the diagonal points, the highest value is 0.85. So 0.85, which is 0.5 and 0.6, similarity between 0.5 and 0.6. So these are the two.
We actually have a 0.95.
0.9. Oh, okay, yes. 0.95. So 0.95, this 2 and 3. So these 2 points should be merged first, and then after that I think 0.85 is the highest. This one, which is between 5 and 6. So the next iteration 5 and 6 would be merged, and then in the third step, then again we have to find out the highest similarity, and now the highest similarity would be 0.80, which is between 4 and 5. So 5 is already part of this cluster 5 and 6, so 4 would merge with this cluster containing 5 and 6. And now then the next highest value from this similarity matrix is 0.75, which is the similarity between 0.3 and 0.4. So 0.4 is part of this cluster 4 5 6, and 0.3 is part of the cluster 2 and 3. So these two would merge. So and finally this one will merge with all the other points, and it would form this dendrogram structure or the hierarchy of the clustering. So this is same as option D. So option D would be the correct answer. So this is how you have to, in every step you have to find out the next highest value, and based on that you have to merge those two corresponding clusters. So option D is the correct answer. So these were the questions that I wanted to discuss today in this problem solving session. So now if you have any doubts regarding the questions or answers that I discussed today, you can ask me, or if there are any other questions or doubts, you can also ask me. Is there any questions or doubts? Okay, so as there are no questions or doubts, so thank you everyone for joining this problem solving session. I have a doubt about examination system. Prashant, so the examination and these things are not handled by this live session TAs. So you can ask your doubt in the discussion forum. There the normal regular TAs and also instructor is present. They would be able to answer your questions. We don't have any knowledge about how the examinations would be there or the syllabus of it, so we don't know much about that. So you can ask in the discussion forum. Yeah, you can ask in the discussion forum. There the NPTEL admin and also the regular TAs are present. They will be able to answer your questions regarding exam. So thank you everyone for joining this meeting. If there are no other doubts, we will end this meeting here.